Hello, and welcome to another tutorial on Murder, the Murder Engine, a pixel art ECS game engine built on top of MonoGame. The first tutorial covered setting up a basic character and movement. As you can see here, we have 8-directional movement as well as animations from a sprite that match. While the animation system is optional, I would recommend getting the player set up before continuing on this tutorial. If you'd like to see tutorial 1, please check the description below. Our goal for today's tutorial is to create an enemy that damages the player when the player collides with it. This could include non-moving hazards, bullet hell projectiles, and platformer enemies. Optionally, it'd also be useful if the enemy dies after dealing damage, such as bullets, so we can clean them up. And the player will die after taking too much damage, so we need some kind of HP system. There'll be a good portion of code involved today, and in fact, pretty much the first thing we're going to jump into. So let's close our game for now and get into Visual Studios. To start off, I'm going to want to create a few components. To do that, I'm going to add some new items. And I could create a class, but I'm not actually going to use a C# class. And I could just make a blank code file. However, this really is a truly blank code file and won't even include the namespace. So if we do make a blank code file, we have to type the namespace manually, and that's a bit annoying. So for the sake of demonstration, I will make a class, but just know that we will change it in a moment. I'm going to call it a health component, because that is what we're going to start off with. We need a way to track how much health something has. Otherwise, we won't be able to deal any damage. We won't have a way to measure that damage. So I'm going to start off by changing this, as I said, from a class to a public read-only struct. And a read-only struct is going to inherit from a component of bang.components. So we're going to need the bang.components here. And we're going to start setting our internal variables, which is our health. Additionally, it'll also be useful if we have a way to know the max health of the player, in case we want to heal them. Because I'm setting up a read-only struct, I need some constructors. And I'm creating a blank constructor, but the true kind of constructor that I'm going to want to use is one that references our internal properties. So we have our health and our max health. A nice handy little suggestion here is to set the health equal to the incoming health and the max health. I don't need this. And now I'm going to set up 2 functions that I can use later. I'm setting them as internal, and we will see later how they're kind of used. So one is to deal damage to the player. And because we're using a read-only component system, what we're going to basically do is set up new components. And here I want to calculate how much damage the player has taken compared to their current health so that I have a new health value. And just for the sake of making sure I don't drop the player below 0 health, I'm going to use math.max to make sure that the health does not drop below 0. And then I will need to also pass it the max health. The next function will be to heal the player. Now we're not going to have time to set up healing functionality, but I did want to include it, because it's pretty much the opposite of what we're doing. So here I want a math.min, and I want to make sure that the health plus the amount healed is no greater than the max health, and that I also pass the max health. So the next thing I want to do is build another component, which is the damage dealing component, and I'm going to call it DealsDamageOnCollision Component. I again need to turn this into a public read-only struct that inherits from iComponent. We're going to have one internal integer here, which is the amount of damage it deals to the other entity that it collides with. We want to give it a constructor. That's an empty constructor, and now we'll have our constructor with our actual damage variable passed to it. And that's it. Let's launch our editor now. So now that we've created those components, our step 1 was creating a health component. Step 2, creating a deals damage on collision component. Step 3, want to add our new components to our 1 prefab at the moment. I have this player 1 backup. We won't be using that. We're just going to be using this player prefab. So I'm going to add a health component. I'm also going to add a deals damage on collision component. We also need something called a interact on collision component. And that's built in, so we didn't need to make that. Finally, we can get an interactor component. Now, one thing, our collider is set to be an actor, which means it will move around with agent physics. We also want our actor to be solid. We want it to have a hitbox. And we want it to be able to trigger these interact events. So with these 4 layers selected, it's possible we don't need all of these. For example, it's not necessary that it's solid. But with these, we have a pretty good character base that we can use to make any kind of character from. If we don't want movement, we can simply remove the player component. And with the player component removed, what I actually want to do is firstly rename this to be called character base. Going to save that. And then I can right click on the character base in the prefabs section here. I'm going to create an instance. I'm going to create 2. The first one is going to be our player. And once we save it, it's going to be called player.json. And we're going to create a second instance. We're going to call this enemy. And now we have 2 instances of the same character base. And they have all the components basically identically. For the player, we're going to add back our player component. Now we should be able to still control this. For our enemy, just to make it clear, I will be importing another A-sprite. So I've simply recolored our sheep to be white instead of black. I'm going to make sure I save that inside my Hello Murder resources, images, character, exactly where our shadow clone sheepsu is. And I've just given it a different name as well. So with that done, I should be able to, again, go into my reload, content, and atlas. In my generated, I should have 2 characters here now. Go to the enemy and change this instead to the little lamb. For now, I can just check it by changing the directions, but it's basically identical, so there shouldn't really be any problems there. I'll make sure I save that. In our world, this player is the player base. It's actually the character base. So let's just delete it. My other types of characters don't show up here. So what I actually need to do is I need to go into this and select this little eyedropper to show this entity on the world entity picker. Save that. Go into my enemy, show entity on world picker. And now you can see I have technically 3. I have my character base, my player, and my enemy. But since I can hover over it and see the names, I can set my player in the world. I can set my enemy in the world. If I play this, I only control my player. And I can collide with the other sheep. But other than that, I don't have any damage or anything just yet. We have a few more steps to go. And the next thing to build is our systems. So we added our new components. And we also added the InteractOnCollision component and interactor component to player and enemy prefabs. Optionally, create a character base and create prefab instances. Step 4, we're going to need to set up our first system. This first system is called the InteractOntriggerEnterSystem. And this is handily taken from the MonoGame project that is provided as part of the open source murder codebase. However, I will show you how it is made. And we're going to put it in our engine. So to start making this InteractOnCollisionSystem, we're going to want to be in the systems folder. And because this is an interaction, we can keep our interactions between items in their own folder here. So we're going to create a new folder called interactions. And in here, we're going to make a new file. InteractOnCollisionSystem. The InteractOnCollisionSystem is in fact a class. So this is fine. And is going to inherit from the iMessenger system, which is from bang.systems. And we need a function called public void onMessage. This takes in the world, the entity, and something called iMessage component. Handily, I can see that I can implement this interface and it will create all of this for us. Hovering over this error message, we can see that this error message says that system requires messenger attribute. Because it is an iMessage system, it needs a special type of attribute called the messenger attribute. The messenger attribute needs a type of, basically what kind of message is this messenger going to relay. The message that we're looking for is called OnActorEnteredOrExitedMessage. Additionally, because I'm not necessarily going to care about all actors that enter or exit each other, this system is specifically going to care about and filter out anything that does not have a InteractOnCollision component. I'll have to use murder.components. I'll have to use murder.components since that's where the InteractOnCollision component lives. And now, finally, we can start building out our message. The message handling. We know that the messenger is going to only listen for OnActorEnteredOrExit messages. So we can grab the data by casting to this type. And we need to do a bunch of checks to make sure that this entity is actually valid. Otherwise, we're probably going to end up with a whole bunch of errors as we try to work with these entities and destroy them and things like that. So one thing we're going to do is get the entity ID. And we're going to make sure that the world actually contains this entity. If not, so if the entity is not actually an entity, even though we've been given an entity ID, that could mean that it either doesn't exist in the world anymore, or for some other reason, this ID is not actually an ID for an entity. It could be an ID for a system or something else, and we have gotten our messages somehow confused. We also want to check that the interactor entity is not marked as destroyed, or that the interactor entity is missing the interactor component. If it's marked as destroyed, or if it doesn't have that interactor component, then it's not something valid to interact with. The interact on collision is going to get the interactive entity dot get interact on collision. So we're going to get the interact on collision component. We didn't really look at the interact on collision component, so actually let's do that first before we start mucking about with it. So if we go to our characters or any of them, and we check out the interactor component, that's empty. So all it does is mark this entity as something that can interact with things. And our interact on collision component has a few elements here. So for example, we can say that this should only ever activate once. If it should send a message when the object stops colliding. If it should send a message every frame while colliding. This is useful if you want some ongoing damage effect, although you probably want to mitigate that by not damaging every single frame, but rather having some kind of timer or tick system. You can also trigger custom events here, and you can select specific interaction components to assign, but we're not going to be using these for the moment. Finally, we can check whether only a player is able to activate this interaction. Therefore, if you wanted things to only affect the player, this would be a quick, easy way to do that. Back to our code. We want to check that our interact on collision player only and interactor entity dot has player. If so, we're going to return. Else, if our message is that movement is happening and we are exiting the collision, we're going to check for each of those interact on collision custom exit messages, and we can do this interaction dot interact with the world and the interactor entity. Now this for loop is not something that we're actually going to need right now, but it is something that could be useful later if we do want to set up these custom exit messages. So it's useful to have this here since we're building out this right now. We could just skip over it and come back to it later, but since it's already included in the file that their example gives us, let's include it as well. And then we won't forget it to add it later. Finally, in this else if, we're going to check if we have no send message on exit, then we're just going to return. Now, all checks complete. It is safe to trigger. Finally, the actual important bit. Interactive entity dot send message. The send message is the core of this interaction system, and the thing we want to send is collided with message. Interactor entity is going to be the thing that it collided with, and we're going to assign the entity ID. So to the interactive entity, we are going to send a collided with message, and we're going to pass it the interactor entity ID so that it can reference what it was just collided with if it needs to. Finally, if the InteractOnCollision has the only once property, then we are going to remove the InteractOnCollision. It will no longer have this component, therefore it should fail our checks. All right, we are going to create a colliding damage system, which will handle the actual collision. And then just to make sure we're understanding the flow of things here, we are then going to create a OnDamagingCollision system. And the reason we're sending these two things out is so the first thing can handle right away on the physics step of colliding, and the second thing is going to handle the individual entity that was collided with. So first, to make the colliding damage system, I'm going to add another folder into our systems here, because this is going to need to be in the physics. So I'm going to create a new file. I'm going to call it Colliding Damage System. And now, just like before, I need to make it a public class, Colliding Damage System, and it is also going to be an iMessenger system. It's going to take the message we just previously validated. Therefore, it is going to need the messenger attribute. This time, we are looking for the collided with message. And for the colliding damage system, since it's specifically things that we can damage, we only really want to send this message to things that have the health component attached. I'm going to implement the interface. And now, say I can log this interaction, so I know that it's happened. Handling collision with health entity. It just needs to be a short and sweet log, just to make sure that we are actually receiving this message through from one system to the other. Now, the meat of the message that's passed along, just like before, since we know we can only be passed collided with messages, casting it is just fine. And we want to get the interactor, etc., from the world. So we're going to get the entity. And we've basically just done all the checks to make sure that this other entity was all valid. So it should still be valid. We could add more checks here if we really needed to, if we knew that other systems were going to run in between these two. And then we're going to want to handle the collision. So I'm going to make a new function here. And it can be a static function. There's no class variables here to worry about. And within this is specifically where we want to handle the logic by making sure that both entities know that they are being damaged. And if for some reason we disable the health component on an entity, or we have an invulnerability state of some kind, then we can also just ignore it. Something we don't have here is a way to send a different kind of message, because we want to handle the message on both entities. So message, and we want to make a new message type here that we can handle in our OnDamagingCollisionSystem. So this will run for both entities, and we need a way to inform it that it is taking some damage. The way we can do that is by adding a new message. Add new item. We're going to call this something like DamagingCollisionMessage. So DamagingCollisionMessage, and this is going to be not a system, not a component. This is going to be a message. So we need to make it a public read-only, and this will be a struct, not a class, of type iMessage. Some information that will be useful here, based on what we had before, a public read-only int called damage dealt. So that's how much damage the entity will do to the other entity. And in case we need reference to the original entity or to the entity that's damaging us or damaging this entity, we can include the other entity ID. Now we do want a constructor on this. The default constructor is not going to be that useful because we're not actually planning on using it. So we can just make this into the type of constructor that we're actually planning on using, which is with the entity ID. And I'll just put the damage first because that's the one that we put first in the order here. And we will need the base constructor, but it is just a default constructor. So we can just call the default constructor like that. Now damage dealt is equal to damage dealt, and other entity ID is equal to other entity ID. And now our message is complete. Back to the collision system. With our damaging collision message generated, we can make 2 of these, one on each entity. And now we need to assign it. So in order to assign the parameters here, we actually want to basically get the damage. And I'm going to use a try get because, again, we don't know that it actually has a deals damage component. And with the entity extensions, we can basically just ask for the deals damage on collision. And this gets generated from the deals damage on collision component. We didn't have to write this. It comes with a get, a try get, a set, etc. Very handy. It is a function. So we're going to try and get the damage. We're also going to use the question mark operator here in case that comes back as null. And if it is not, then we want to get the damage out of it. Otherwise, null coalescing operator, we are just going to tell it that it takes no damage. Then we want this entity to entity ID, again, just in case we need to look up. Okay, now we can basically take this whole section and we're going to make this entity 1. Pretty straightforward messaging system to both entities from this single collision. So now that we have created our colliding damage system, send to damaging messages from one collision message, we now want to handle those 2 damaging messages on each entity separately. So we're going to create this OnDamagingCollisionSystem to do that. This is also what I would consider an interaction. So I'm going to create a new item in the interactions folder, and I'm going to call this OnDamagingCollisionSystem. The OnDamagingCollisionSystem is a iMessenger system. It needs to know what type of message it is listening for. So we'll give it the messenger attribute with the type of damaging collision message that we just made. And we need to remember to include the filter, type of health component. And now we also need to implement the interface for the onMessage. So this is where we will actually handle the individual damage collision messages for each entity at a time. So the entity that's passed here is the entity that was sent the message. Now I'm just going to set another log for us here as well. Processing collision on specific entity. As previously, since we know the messenger is going to filter out a specific type of message, we can safely cast our damaging collision message to our message. And now we can basically apply the damage. There really isn't any other step that we need to do. I'm going to track how much HP the entity has. Then I'm going to call entity.getHealth. Now, since we directly have access to this health component, we can call the damage function on it. So that actually will get us in here. And then all we need to pass is the damage taken, which we get from our message. So the damage that was dealt is now the damage that is taken, and the entity will get a new health component applied to it with the new health value, and then that gets returned to us. So HP after damage right now is the health component, and if I just want the final health amount, I could check the current health. So now I can check the current health, and the HP after damage is just the health. Here would be also where I might play any collision VFX or SFX. Finally, I'm going to clean up the dead entities. So if our HP after damage is less than or equal to 0. Now something that's optional, an optional way to build this would be to use something that is already kind of built in. So we would send a message, and there's a component that already exists, or a message type that already exists, called Fatal Damage Message. So we could send a fatal damage message and have some other system handle fatal damage. For the sake of this tutorial, so that we actually have something working, rather than building a whole other system to handle fatal damage, I'm just going to build it right into this. And the way I want to do that is actually to create a coroutine. And we're going to use something called the wait, which is from the Bang state machines. It's going to be a useful way to run coroutines in, well, we're not in Unity or something like that, so we don't have those kinds of built-in coroutines. But Bang, the Bang engine has its own sort of built-in coroutine system, so we can use that for simple wait operations. We might be able to do async with C#, but then we have a bit more overhead to work with. So it's just useful to be able to build in, use the built-in Bang. So this is meant to work specifically with the murder engine. Now I need to call my coroutine. To do that, I'm going to use something called coroutine services.run coroutine. I need to tell it what entity is running the coroutine, so I'm going to give it the entity. And then I need to tell it the coroutine to run. And then here, I also need to pass the entity to this function, so I have it locally. Then I have to actually decide what I'm going to do when I clean up the entity. For example, I can do entity.remove collider. Then it's going to remove this component from the entity. Another thing I could do is set a speed override. And since I know I'm working with agents in this project, by setting a speed override, I can zero out its speed and make sure that something that is dead comes to a stop. Now, because I'm using a coroutine, I probably want to wait on something. And so in this example, because I am setting the agent speed override, I expect that this entity will come to a stop. I can try and see that there's a velocity component. If there is a velocity component, that means that the agent is still in motion. Once the agent's velocity is 0, the velocity component gets removed, and therefore the velocity should be 0. I don't have to worry about floating points and trying to find some number that's close to 0. I can just see if there is a velocity component on the agent or not. Once we set its speed to 0 and it comes to a full stop, then its velocity component will be removed. Until its velocity component gets removed, I want to wait for the next frame. So this coroutine will wait the number of frames it takes for the velocity component to get removed. And then I can clean up the entity by calling entity.destroy. And that should remove it. Just like in our first tutorial, these systems are not added to the base game features by default. We need to add them in the appropriate place so that they run in the appropriate order and they handle everything. So we need to add the InteractOnCollisionSystem to the character features. And we need to add the colliding damage system that we made and the on-damaging collision system that we made to the physics features. And now I can go into my features section, go to character, and add the InteractOnCollisionSystem. Make sure that's saved, then go to the physics, and I can add my colliding damage system and my on-damaging collision system. Now you'll recall how the order of these systems is important, and while it takes a lot of time to put something somewhere, check to see if that's the right place, move it, check it, once you start to have a better understanding of how these systems work from one thing to the other, you'll start to understand the order of operations that things need to be in. So for example, the colliding damage system, if we move it up to be before the trigger physics system, then we can ensure that after it's moved, it'll check if it collides, it'll do any triggering of physics objects, and then finally it will do the damaging at the very end of the physics steps. With that all in place, let's try it out. One thing we didn't do was set health and damage components, so we'll see what happens. And yep, both of our entities just disappear. So to make this a bit more game-like, let's go to our player, let's go to the health component, and let's actually give him some health. We can set the max health to 3 and the current health to 3. If we wanted to start the player in an injured state, we could set the health lower than the max health. For our enemy, just for a quick example, let's just give them 1 health, 1 max health, and make sure we save both of those. Now when we play, you'll notice that we've killed the other entity by running into it. If I go to my world scene, and I just drop a few more of these into the world, it should be 1, 2, 3. I should be dead. What we'll actually should do is get the HP after damage component and then call entity.setHealth. And we can give it the HP after damage component. That way, the HP of the entity actually gets set as this new value. That does mean that we need to change this to get the health out of the new HP after damage component. But now our character should take damage and its health should decrease each time it takes damage by the number of damage dealt. And now when we collide with the different sheep, our health should be ticking down until finally it's at 0. And then we die too. One thing that it looks like we may be missing is that we don't die until we come to a stop. Funny enough, it looks like we just keep moving in one direction, possibly until we die. So what we probably need to do here is disable the input system of some way so that we don't keep moving frictionlessly. One thing we might need to do here is check to see if the entity.hasPlayer, and if it does, as in this is a player controlled entity, we can do entity.removePlayer. So it's no longer player controlled. And there you go. We die immediately. Now there may be other considerations in here that you'll discover as you play around with this. Say if you do add collision VFX, SFX, if you want to play a specific animation when the character dies, so you may wait more than just the next frame, you may have to wait for some animation to finish. There's a whole bunch of things that we can add in here. But in terms of completing our steps, yes, it is a bit of a big list. However, some of these steps were pretty quick to do, and once we learned how to set something up once, say a component or messenger system, we were able to build the second one fairly quickly. I would say that concludes the tutorial number 2. Thank you for watching. I think next steps, projectiles, enemies that move fixed or toward the player. Then later, UI tile sets. Once we have this next step done, which hopefully is tutorial number 3, we should have the basics of a game, getting UI and tile sets to make that game feel more complete, and then adding effects, sounds, and other things. Game enhancements. Till next time, take care.